Let's talk about the psychological comfort of the safety net. You walk onto a trapeze platform, you look down, you see that grid of ropes below you, and your brain just instantly recalibrates your risk tolerance.
Right, you feel invincible.
Exactly. You don't inspect the material of the net, right? You don't ask the venue manager when it was last load tested. You just see it, you assume it functions perfectly, and you take the jump.
Yeah, it's just human nature to trust the infrastructure.
Right, and that exact same psychological blind spot dictates how millions of people manage their digital infrastructure today. I mean, when your entire livelihood is hosted on a massive publicly traded platform, you see the scale of their servers, and you just assume there's this universal safety net catching every single mistake you make.
Which is a terrifying assumption when you really look at it.
It really is. So today we are taking a deep dive into a comprehensive guide published just yesterday, August 14th, 2026. It's titled Backing Up a Shopify Store, What Restores, What Doesn't.
Yeah, a very necessary reality check.
Okay, let's unpack this because the central premise of this text absolutely shatters that illusion of safety. Merchants operate under the assumption that a platform like Shopify has these magical, all-encompassing recovery tools. But the reality we are going to explore today is that the platform actually restores far, far less than people think.
I mean, it is arguably the most dangerous misconception in e-commerce infrastructure right now.
Totally.
The mission for you today, whether you're managing a high-volume enterprise operation or maybe running a lean boutique or just simply fascinated by the architectural realities of cloud computing, is to dissect the anatomy of a digital disaster.
Yeah, we're getting into the weeds.
We're going to map out exactly what happens when data is lost, what components are genuinely recoverable, what evaporates permanently, and the specific operational thresholds we're paying for third-party protection transitions from a luxury to an absolute baseline requirement.
And the core of this entire vulnerability really seems to stem from a massive industry-wide definition disconnect. I mean, we really have to look at how we define our terms here.
Yeah, semantics matter a lot in this space.
They really do, because when you or I hear the word backup, we are conditioned by consumer technology to think of it as a passive, automated safety net. Like, I assume my phone is backing up to a cloud server at 3 a.m. while I'm asleep.
Right, you don't even think about it.
Exactly. I don't initiate it. The operating system just handles it. But when you dive into Shopify's official documentation, the word backup functions completely differently.
Yep.
They use it as an instruction for the merchant. A backup to the platform means you, the merchant, manually navigating into the admin and generating a CSV export of your data.
Mm-hmm. The terminology clash is jarring. I mean, the documentation is not describing a background service they manage for you. It is assigning you homework.
Yeah, you do it.
Right. And relying on a manual CSV export fundamentally misunderstands how data is structured in modern commerce.
How so?
Well, a CSV is a flat spreadsheet, right?
Yeah.
It exports the raw text of your products or your customers, but it completely strips away the complex relational architecture of your store.
Oh.
Yeah. So if you have custom meta fields mapping specific materials to specific product variants or intricate image associations, a flat CSV export just struggles to capture that structural context.
It's the architectural equivalent of having an insurance policy that only covers the raw lumber of your house, but not the blueprints or the actual construction.
That's a perfect analogy. Yeah.
You have the materials, but you still have to figure out how they fit together.
And usually while you're panicking.
Right. But I want to push back on this reliance on CSVs for a moment, because the platform isn't totally devoid of native recovery tools. Like, there is the timeline feature. If I'm editing my storefront and I break a critical piece of formatting, I can revert the state of that file, right?
Well, the timeline tool exists, but its boundaries are incredibly rigid. It acts on a micro level, not a macro level.
Meaning what, exactly?
Meaning you can revert the code history of one single specific file. It does not have the capability to roll back your entire theme state to a previous point in time.
So no system-wide undo?
No, not at all. Furthermore, if you accidentally delete that file entirely, the timeline history tethered to that file is permanently destroyed with it.
Oh, so the history dies with the file.
Exactly. And there is another operational catch. When you do restore a previous version of a file, it overwrites the current file entirely. So any legitimate positive changes you made alongside the error, yeah, those are also rolled back.
So it's a highly targeted scalpel, not a system-wide time machine.
Right.
And the limitations get even stricter when you look at the visual theme editor. You know, the interface where merchants drag and drop promotional banners or rearrange product grids without touching the raw code.
Yeah, the drag and drop stuff.
Right. So the interface gives you the standard undo and redo buttons. But the guide highlights a terrifying architectural reality here. The second you click save, your entire session history is wiped clean. You can no longer undo those visual customizations.
Yeah, and the underlying mechanism there comes down to how web applications manage memory.
Okay, break that down for us.
Sure. So the visual editor operates on a temporary session-based cache held locally in your browser. It allows you to freely experiment without constantly pinging Shopify's database.
Right, makes it faster.
Exactly. But the moment you initiate a save command, you are telling the platform to commit that temporary state to the live authoritative database.
And then what happens?
To optimize server load and maintain rapid performance across millions of storefronts, the platform immediately discards the temporary cache. The commit is final.
Wait, so the commit is just final? That finality makes the save button incredibly dangerous.
Extremely.
But it completely contextualizes the platform's approach to the delete button. Because, I mean, we have been trained for decades by personal computers to treat the trash can as a holding pen.
Right, the recycle bin.
Yeah, a deleted file just moves to a different folder until you explicitly decide to empty the trash. But the source material makes it painfully clear that on this platform, deleting a product is a permanent database purge.
Yes, immediate and permanent.
The text actually includes a chilling scenario from January 2025. A store owner went onto the community forums in a total panic because they had accidentally deleted their entire catalog of 3,000 products.
Oh, man.
Yeah. And the only artifact the platform provided was an activity log listing a massive string of meaningless internal product IDs. That was it.
See, implementing a universal soft delete where a platform hides the data from the user but retains it on the server, just in case that requires massive storage overhead.
Right.
When you scale that across a global infrastructure, keeping shadow copies of every deleted inventory item or product variant becomes computationally and financially unviable.
So they just don't do it.
Right, so the database executes a hard delete. It purges the rows, there is no hidden grace period, and there is no documented support-side recovery window where you can escalate a ticket and have an engineer roll back your server partition.
The system is optimizing for its own efficiency, not for user error. But, you know, as I'm looking at the source text, there is a fascinating contradiction in how the platform handles deletions. If you try to delete a customer profile, the platform suddenly becomes incredibly protective. Like, it will aggressively intervene and block you from executing the deletion under a variety of circumstances.
What's fascinating here is where technical efficiency collides with real-world legal and financial liability.
Ah, okay.
A product is simply your data, right? A customer profile intersects with global compliance frameworks.
Like GDPR.
Exactly. The system's architecture will outright refuse to let you delete a customer if that profile has a pending GDPR erasure request attached to it. It will also block the deletion if the customer has an active subscription or is scheduled to receive a digital gift card or is tied to an unfulfilled order.
Oh, wow.
The platform essentially locks the database row to prevent you from breaking international privacy laws or severing a pending financial transaction.
Which means the platform is perfectly capable of building guardrails when it protects them from legal exposure, but they just leave the guardrails off when it comes to your catalog.
That's one way to look at it, yeah.
The text is also careful to distinguish between deleting a profile and fulfilling a privacy request. Erasing personal data to comply with a framework like GDPR requires a redaction process. Redaction strips the personal identifiers, the names, the physical addresses, but it preserves the transactional ledger so your accounting doesn't break.
Right.
Deleting the profile entirely is a different, highly restricted action.
Because the compliance infrastructure requires an immutable ledger of transactions. You cannot simply delete the history of money moving through the system, which is why redaction replaces deletion in those legal scenarios.
So if a hard delete is a permanent death sentence for a product, the actionable takeaway for you listening is to aggressively adopt the one built-in safety net you actually control.
Archiving.
Archiving. Archiving changes the status of an item, hiding it from the live storefront, while perfectly preserving its database row and all its associated data. But the massive operational catch is that archiving requires anticipation.
Yes, think ahead.
You cannot retroactively archive something you just deleted. You have to build the institutional muscle memory to click archive instead of delete when you are managing old inventory.
It requires a fundamental shift in daily operations. You must assume that recovery will be necessary before you execute any administrative cleanup. cancel, or archive, but never permanently delete.
Now, a logical merchant looking at this landscape, the lack of automated backups, the permanence of the delete button, they might try to engineer their own workaround.
Sure.
The most common instinct is to simply duplicate the entire store. You pay for a secondary dormant account, clone your live store over to it, and keep it sitting in reserve.
It sounds so smart on paper.
Right. If the live store gets corrupted, you theoretically just change your domain routing and point your traffic to the backup store. It sounds like a bulletproof, redundant infrastructure plan. So what does this all mean? If I just duplicate my store, I have a perfect clone sitting in reserve, right?
No. It is a highly rational assumption that completely unravels when you look at the strict data boundaries enforced by the platform.
Let's break those down.
The guide systematically details 6 gaping holes in the store duplication process. It is not a one-to-one clone. The most critical failure point is the transactional history. Shopify's documentation is explicit orders cannot be imported into a new store through the administrative dashboard.
Let's explore the mechanics of why that is, because an order is not just a digital receipt you can copy and paste, right? It is a locked financial record tied to a specific merchant ID, a specific payment gateway account, and specific tax routing rules.
Exactly.
If the platform allowed you to freely export and import historical orders across different store instances, it would create an auditing nightmare. You could theoretically fabricate trading volume or obscure tax liabilities.
The integrity of the financial ledger demands that transactional data remains permanently tethered to the original store instance, which means your duplicate store is blind.
Blind.
It possesses zero record of anything anyone has ever purchased. Every single customer lifetime value metric, every sales forecasting report built on historical data, it all stays behind.
It is the equivalent of cloning a physical retail location. You manage to perfectly replicate the paint job, the window displays, and the shelving units.
Right.
But when you open the doors, the cash registers are completely empty, your entire customer Rolodex is missing, and to make the situation even worse, you still owe the financial liabilities from the old location. Because the guide points out that active discount codes and issued gift cards do not transfer during a duplication.
Yeah, that's a huge one. A gift card is essentially unsecured debt.
Right, you owe them.
It represents a balance of funds that your business owes to a consumer. The platform does not automatically migrate those financial liabilities to a new, separate store architecture.
So you're just on the hook.
If you were forced to migrate to your duplicate store during a disaster, you would have to manually reconstruct every outstanding gift card balance and rebuild every active influencer discount code from scratch.
That sounds like a nightmare. And there is one final brutal reality check regarding the duplicate store mirage: the intellectual property rights of your storefront design.
Ah, yes.
If you are operating on a premium paid theme from the Shopify theme store, that code is licensed exclusively to the original store URL. Your duplicate store isn't legally authorized to run the architecture you paid for.
Right, you had to buy it twice.
So duplication is a complete dead end for disaster recovery. It's a staging environment, not a safety net. This naturally forces us to pivot to the third-party ecosystem. Where a platform creates a functional void, software developers build solutions.
The marketplace dynamics are highly predictable. The limitations of the native platform create a lucrative opportunity for specialized data protection services.
Right. The source text evaluates the landscape as of August 13th, 2026, highlighting the two dominant players in this space: Rewind and Backup Master. Both operate on a baseline subscription of $19 a month for a live store processing up to 300 orders.
And that scales up pretty quickly.
Oh, yeah. The tiers scale up based on volume, easily reaching $99 a month for higher traffic. But here's where it gets really interesting. A merchant authorizes that $99 monthly charge and assumes they have purchased absolute impenetrable immunity.
Oh, absolutely.
They assume the app wraps a protective layer around every single byte of data on the server. I mean, if I'm paying $19 or even up to $99 a month for a higher tier, shouldn't it cover absolutely everything?
You would think so. They assume the application has root-level access to the server. But these backup solutions do not operate at the server level. They operate exclusively through Shopify's API, the application programming interface.
Okay, the API wall.
Right. Think of the API as a heavily guarded checkpoint. External software approaches the checkpoint, presents its credentials, and the API dictates exactly which rooms the software is allowed to enter.
And some rooms are locked.
Exactly. Rewind's own technical documentation is remarkably transparent about this limitation, stating plainly, items we can't back up are items we can't see.
And the platform intentionally blinds these apps to some of the most critical infrastructure in your store. The API completely walls off store settings.
It's a huge blind spot.
A backup app cannot see your shipping zones, it cannot access your international market configurations, it cannot read your store policies, and it has no visibility into your staff permissions. Let's look at why the platform enforces that blind spot. Because it's not arbitrary. It is a matter of pure security architecture. Your store settings contain the core routing for your physical logistics and your financial compliance.
Right, if the platform granted a third-party application right access to your core settings, they would be opening a massive attack vector.
Like a backdoor.
Exactly. If a malicious actor managed to compromise the backup app's servers, they could theoretically push an update through the API that subtly rewrites your shipping logic or alters your payment gateway routing.
Oh, that would be disastrous.
But neutralize that threat, the platform's OAuth scopes the permissions matrix, strictly prohibit third-party apps from interacting with those sensitive endpoints.
The security logic is sound, but the operational reality for the merchant is that your expensive backup subscription cannot save your shipping rates. If a staff member accidentally deletes your international shipping zones, the backup app cannot help you. You are rebuilding them from memory,
Which is painful.
which introduces a vital vocabulary shift from the text. The guide emphasizes the profound difference between data being backed up and data being restorable. Let's say you accidentally scramble your complex drop-down navigation menus. The backup app likely has a copy of that menu hierarchy saved securely on their own servers. They have the data.
But possessing the data does not grant them the API permission to dynamically inject that menu structure back into your live Shopify interface.
Ah, so they can't push it back.
No, they cannot automate the recovery. In scenarios involving navigation menus, specific store policies, or customized gift card products, the backup service acts as an archival reference.
Okay, so what do you actually do then?
You have to open a support ticket, retrieve the saved data from their vault, and manually rebuild the architecture within your admin panel, brick by brick. It is a manual reconstruction project facilitated by external data rather than a magic restore button.
You are paying for the blueprints, but you still have to do the manual labor of rebuilding the house. Understanding these API limitations completely changes how a merchant calculates the value proposition of these services. Which leads us to the final, highly practical application of this source material, the decision matrix.
They're making the call.
How do you objectively evaluate whether your specific operation needs to absorb the cost of a dedicated app? And what is the operational protocol if you choose to rely on free manual routines?
Well, the financial baseline is straightforward. The entry-level tier for these services requires roughly $228 a year, with Backup Master offering a slight optimization at an annual rate of $205.20.
Right.
But evaluating the true cost requires looking beyond the subscription fee. You have to quantify your operational vulnerability. You must price the raw hours your last data mistake cost you to fix, and weigh that against the sheer operational downtime of manually reconstructing a corrupted catalog from an outdated spreadsheet.
And the guide introduces a brilliant foundational paradigm shift for making this calculation. It argues that merchants continually evaluate their risk based on the wrong metric. They decide whether they need a backup based on how careful they believe they are.
Which is totally subjective.
Right. The text insists that your personal diligence is irrelevant. The decision must be dictated purely by access control. You decide based on who or what has the ability to change the state of your store's database.
It is an objective assessment of threat vectors. If you are a completely isolated solo operator, making deliberate, infrequent changes to your catalog, a rigorous manual routine may be entirely sufficient. You control all the variables.
What's the moment you add someone else?
But the moment you introduce external actors, the risk profile changes exponentially. Hiring an external design agency, adding staff accounts with editing privileges, or installing third-party inventory management software that pushes data to your store via the API, each of these elements strips away your absolute control.
Because data corruption doesn't just happen when you accidentally click the wrong button. An automated inventory sync app could push a flawed update that overwrites your product descriptions at 3 a.m. on a Sunday. You aren't awake to catch it, and you certainly weren't careful or careless in that moment. That is the exact threshold where an automated backup app capturing the delta of those changes becomes necessary infrastructure. But for the sake of the solo operator who maintains strict access control and opts for the free route, the guide details a highly specific manual routine. It is not just a few clicks. It is a stringent operational workflow.
It is a standard operating procedure that requires immense administrative discipline. The foundation of the routine, this is step 1, involves routinely exporting the CSV files we discussed earlier.
Got to have the raw data.
You must secure the raw data, despite its architectural limitations. But the workflow extends far beyond flat spreadsheets. Step 2, before you execute any modifications to your themes code, you must duplicate the theme.
And the operational friction here, step 3, is that you cannot just leave a dozen duplicated themes sitting in your admin panel. The platform imposes strict limits to manage server storage. Basic, Grow, and Advanced plans cap out at a maximum of 20 themes. The Enterprise Plat plan caps at 100. If you reach that threshold, the system blocks you from saving any new iterations. So the workflow requires you to physically download the duplicated theme files to your local hard drive.
Which necessitates step 3, active pruning. You must deliberately manage and delete outdated theme copies from the server to prevent hitting that cap.
It's a lot to manage.
It is. Furthermore, because we established that the API completely misses your core store settings, step 4 of a manual routine requires you to build external documentation. You need a physical or digital ledger recording exactly how your shipping zones, tax overrides, and staff permissions are configured, because no software is saving that for you.
It is a massive administrative overhead. You are handwriting the policies the API won't touch.
Yeah.
And the guide emphasizes the critical importance of step 5, using the archive function over the delete button during routine maintenance. But the final component of this manual workflow, step 6, is the step the text claims almost every merchant skips: the functional tests.
Yes, the dry run.
You have to execute a controlled dry run. You must intentionally delete a test product and prove that you can successfully reconstruct it from your CSV exports.
Because a disaster recovery protocol that has never been executed is not a protocol. It is merely an optimistic assumption.
So true.
If you do not verify the integrity of the data and your ability to deploy it, the entire manual routine is an illusion of security.
You don't know if you're wearing a parachute or just a heavy backpack until you actually pull the ripcord.
Exactly.
So bringing all of these technical threads together, being genuinely well-informed in the modern e-commerce landscape, requires active, skeptical management of your platform dependency. It requires abandoning the assumption that hosting a business in the cloud intrinsically guarantees the safety of your data.
The cloud is just someone else's computer.
Right. It's just a server facility in another time zone, governed by rigid optimization rules, strict API permissions, and a highly unforgiving database architecture.
If we connect the mechanics of this deep dive to the broader trajectory of digital commerce, if a multi-billion-dollar platform's foundational architecture fundamentally prevents you, or any specialized software you hire, from fully securing and automatically restoring your own core operational settings, it forces a critical evaluation of ownership.
Yeah.
Who truly possesses the digital infrastructure of modern commerce? Are you a digital property owner, actively building equity and security in your technical foundation? Or are you operating on a perpetual precarious lease where the landlord controls the locks, dictates the structural boundaries, and can wipe the shelves clean without recourse?
You might be allowed to arrange the inventory, but you categorically do not own the building. Thank you for joining us for this deep dive into the source material. We hope you walk away equipped with the technical clarity to actually protect your digital footprint. Check back next time for another extraction of vital insights.